Hi, my name is Pixie, welcome to my channel, and today we're going to talk about nothing! Okay, never mind. I'm sorry, I don't know how else can I explain it because it's just nothing. Or is it? So, what is the widest thing you've ever seen in your life? Well, it's the observable universe. Unexpectedly, its diameter is nearly 93 billion light years. That's kinda big. Wait, what is light year? It's basically the distance that light travels in 1 year, and it's also 9.7 trillion kilometers, or 6 trillion miles. And no, I won't be multiplying that by the diameter of the observable universe. Do it yourself. So, all in all, you are watching this video right now, and you're probably in your room, located somewhere on Earth, and Earth is located in our solar system is located in our galaxy Milky Way, and that is located in our local galactic group. There are over 30 galaxies in it, and its diameter is nearly 10 million light years, so it's still pretty small compared to our observable universe. The local galactic group is located in Virgo supercluster of galaxies, which is part of Laniakea supercluster. Laniakea is a giant galaxy supercluster that contains approximately 100,000 galaxies, including Milky Way. And finally, Laniakea is located somewhere in the observable universe. Fact is that the universe is expanding. That means that if we recorded the expansion and then played backwards, it would be logically shrinking to a certain point, Big Bang. And all this happened 13.7 billion years ago. And those 13.7 billion years ago were very approximately 12% of the universe made of atoms. Another 15% are made of photons, which are practically very little tiny particles of light, or any other type of electromagnetic radiation. Next 10% are made of neutrinos that are, this. Pretend you understand. So there are 63% left. It might appear like it's just nothing, but it's quite not possible. Let's look why. Dark matter. So, what do we know about it? Well, practically nothing. Wait, don't leave. I mean, we can touch it, we can hear it, we can see it. No, just because it's called dark and the universe appears black doesn't mean it's black. It's because space is vacuum. That means there are no particles to scatter light into our eyes. So, how do we even know that it really exists? Well, it appears to not interact with electromagnetic field or even light, and the only thing that it really affects is gravitation. But still, we've gotten observational evidence that there can be just free space. Discrepancies in studies of spiral galaxies. So, this is Milky Way, and the Milky Way is a very friendly spiral galaxy. It means that the arms of the galaxy rotates around the galactic center, and the rotation speed of these arms should be decreasing with increasing distance from the center of the galaxy, and, well, it's not. It remains the same instead. Wait, why is that? Dark matter may be an explanation, but what kind of explanation it is when we don't know what it is? Well, we know that it is not a form of matter we know and see, like stars, planets, you and me. We know that black holes are not made of this dark matter, and we know that it's not antimatter because we would detect the energy produced when it meets with matter. Okay, so let's move away from the dark matter for a moment. Do you remember how I described the hypothetical composition of the universe when it was 380,000 years ago? Yes? Good then, because we're moving 13.7 billion years forward and look on our theoretical model of the composition of today's universe. Dark matter form approximately 27% of the universe. Next is the normal matter, so whole 5% of universe are made of atoms. Okay, great. Now we have just approximately 68% left. So what are the 68% made of? Okay, let's take a little quiz. Who is responsible for the acceleration of the expansion of the universe? You guessed right, it's dark energy, not dark matter. What is the difference, you might ask? Well, unlike dark matter, dark energy is not... Wait, I've got the whole definition written here. Great. So, dark energy is... hypothetical energy uniformly distributed in space, introduced as a theoretical concept explaining the acceleration of the expansion of the universe. Again, I assume that you already forgotten that back in the video I told you that we don't know practically nothing about dark matter. Well, surprisingly, we know even less about dark energy. Well, if it really would exist, one thing's for sure, there is still more and more of it. It's because as we haven't forgotten. The universe is expanding, and the hypothetical consistency of the energy is still the same. And how would that be possible? What? Don't ask me. I have literally no idea. So, what is the conclusion? We live in a simulation and Earth is flat. Bye!